So, hello everyone, this side Mayank Jhunjhunwala from IIT Kanpur. So, today I am going to discuss some past few questions on electrochemistry, environmental chemistry. So, it's again an easy topic from chemistry for JEE Mains and NEET perspective. Of course, it is not asked that much in JEE Advanced, but for JEE Mains, it is an important topic. So, let's start with the questions. So, let's start with question number one. Among the following, the one that is not a greenhouse gases. So basically, again, in this type of chapter, you will get only theoretical questions. So they are asking you among the following, which is not a greenhouse gas. So we know that ozone layer protects us from ultraviolet radiation. So ozone layer protects us from ultraviolet radiation. First thing, methane is found in marsh areas. Okay, let me write it clearly. Ozone protects us from UV radiation. Methane is found in marsh regions. I'm just telling you for your information. Found in marsh regions. And two is laughing gas. Used in laughing gas. Okay. So this is just for information. So among these three are involved in greenhouse effect, and sulfur dioxide is not. So it is not a greenhouse gas. So it's again an informative question only. So sulfur dioxide is the right answer for this question. Sulfur dioxide is not a greenhouse gas. Okay. So let's move on to next question. Question number two. Which one of the following statements is not true? pH of drinking water should be between 5.5 and 9.5. Concentration of DO below 6 ppm is good for growth of fish. Clean water should have a BOD value of less than 5 ppm. Oxides of silver, nitrogen, carbon are most widespread air pollutant. Okay, so let's see. So option number B, the growth of fishes get hindered if the concentration of DO is below 6 ppm, because they are seeing that concentration of DO below 6 ppm. DO means dissolved oxygen. DO means dissolved oxygen. Dissolved oxygen. Okay. So basically, they are saying that concentration of dissolved oxygen below 6 ppm is good for growth of fish. So this is wrong. Actually, what happens if DO goes below 6 ppm, then growth of fishes gets hindered. Why so? Because DO is nothing but dissolved oxygen, and if the concentration of dissolved oxygen goes below a certain level, let's call this level as threshold level. So if threshold level goes down, then fishes will face problem in getting oxygen, so the growth of fishes will get hindered. So basically, concentration of DO below 6 ppm is good for growth of fish is wrong option. It should be above 6 ppm. pH should be between this. It's okay. Clean water should have a BOD value of less than 5 ppm, and oxides are widespread air pollutant. Of course, nitrogen, sulfur, and carbon. We also see that in acid rain. So all the other options are correct. Option number B is wrong option because it hinders the growth of fish. Okay. So moving ahead, question number three. Green chemistry means such reactions which produce color during reactions. It is wrong. Reduce the use and production of hazardous chemicals. Cool. Related to depletion of ozone layer. This is also wrong. Study reaction plants. This is also wrong. So green chemistry just means we are doing that kind of chemistry in which there is less pollution. So it is the reaction which reduces the use of hazardous chemicals in this program of developing new chemical products and chemical process or making improvements in the already existing compounds. and processed so as to make them less harmful to human health and environment. This means the same as to reduce the use and production of hazardous chemicals. Why so? Because when we will reduce the use of hazardous chemicals, then pollution will be reduced. First thing, pollution will be reduced, and the people which are working around these kind of industries will their health will not get affected basically. So green chemistry basically looks out for these two three scenarios. First thing is pollution by the reduction of use of hazardous chemicals, and second it improves the health of those people who are working around these kind of industries. So this is what green chemistry basically means. Green chemistry is nothing to do with color, nothing to do with color, it's just for a name because green sounds good, that's why. Nothing to do with color. It just means that it reduces the use of hazardous chemicals. So reduces the use in production of hazardous chemicals. Option number B is the right option. There is nothing to do with color, not nothing to do with depletion, and study reaction is nothing. All this we have photosynthesis. Okay. So pretty simple questions. If you know, you know. Otherwise, you have to move ahead. So moving on to question number 4. Which oxide of nitrogen is not a common pollutant introduced into the atmosphere, both due to natural and human activity? Okay, so basically, it is asking me which oxide of nitrogen among these four is not a common pollutant, which is produced by both, by environment also, that is by natural, and by human activity also. Okay, so N2O5 is the answer. Why? Because in automobile engine, when fuel is burned, dinitrogen and dioxide combine to yield NO and NO2. So basically, it is saying that in automobiles, when N2 is burned with oxygen, it produces NO and NO2. Okay, this is NO, this is NO, nitrogen dioxide. So N2O5 is not made like that. N2O5 might be due to natural, but it is not human cause because human activity can be read as the pollution which is due to automobiles, which might be due to CFC, due to refrigerators, or due to depletion of ozone layer, which is due to humans. But humans are not involved in any of the activity which directly produces N2O5. It produces NO, it produces NO2, N2O is also produced, but N2O5 is not. It might be released due to atmosphere, but not due to natural activities, but not due to human activities directly. So, which oxide of nitrogen is not a common pollutant? And 205 is the right answer. Cool. So, this was question number 4. Let's move on to question number 5. Which of the following is not a common component of photochemical smoke? So, photochemical smoke, what is photochemical smoke basically? So, what is photochemical smoke? So, photochemical smoke is something like it is a mixture when the pollutants like oxides of nitrogen or sulfur, other compounds which are volatile. Volatile means which can easily be converted into vapor. So the oxides of those volatile compounds like nitrogen react with sunlight to produce a what we say a hazy kind of atmosphere. So basically the oxides of nitrogen or other volatile compounds when they react with sunlight, not basically react, basically when they combine with sunlight, so you get a hazy look. It's basically in the mornings when there is sun and when oxides basically combine with it, so you get a blurred vision due to this photochemical smoke. So photo basically means combination with sun, and chemical means, here photo means combination with sunlight, combination with sunlight, and chemical means for volatile oxides like nitrogen oxide. Okay. So when these two combine, we get a photochemical smoke, producing a hazy atmosphere. Okay. So which of the following is not a common component of photochemical smoke? So we are being asked that which is not a common component of this photochemical smoke. So let's see. So basically, option number D, the oxidized hydrocarbons and ozone in the presence of humidity cause photochemical smoke, as I told you, because of the oxides. Hydrocarbons plus O2 and O2 NOO3, basically oxides of nitrogen, form peroxides, formaldehyde, peroxyacetyl nitrate, which we call PAN. PAN is again an important compound. Its full form is also sometimes acrolein. Hence, chlorofluorocarbons are not common components of photochemical smoke, and CFCs are released by refrigerator gases. Okay, so CFCs are released by gases found in refrigerator. So basically, when hydrocarbons combine with oxides of oxygen, nitrogen, and all, we get peroxides, which is H2O2, formaldehyde, HCO, peroxyacetyl nitrate, PAN, acrolein. These type of compounds we get in photochemical smoke. Photochemical smoke. Okay, so CFC is not a component of photochemical smoke. So option number D is the right option, which is CFC, chlorofluorocarbons. So these three are components, but this is not. So these are formed by combination of oxide with sunlight. Okay, so this is about photochemical smoke. And of course, because it is due to sunlight, so it occurs more often in summer because there is more sunlight in summer times. So this is about photochemical smog. Of course, it is a complex process, but you don't need to go that deep in it because only these type of questions will be asked with you in JEE Mains. Cool. So let's move ahead. Question number 6. Which one of the following statements regarding photochemical smog is not correct? Okay, carbon monoxide does not play any role in photochemical smog formation. This is wrong. Is not correct. Okay. So then let me read all the other options also. Photochemical smog is an oxidizing agent in character. Photochemical smoke is formed through photochemical reaction involving solar energy. This is also correct. Photochemical smoke does not cause irritation in eyes and throat. So option number D is of course wrong because smoke basically means smoke basically means haziness. Okay, so smoke means haziness. Haziness, of course, when we let's talk about the winter mornings here only. In winter mornings also we get fog, we get smoke. So these kind of atmospheric phenomena always gives irritation to our eyes. So option number D is of course wrong, which is saying that it does not cause irritation in eyes and throat. So this is wrong. All other options are correct. Option number A is also not that much correct because oxides are involved, but we need to take that option which is mostly appropriate. So option number D is so absolutely wrong because of course smoke causes irritation in eyes and throat. So option number D is wrong. Option number A, B, and C are correct options. Okay. So this was again an easy one. If you know about photochemical smoke, then you can easily do it. Moving ahead. So let's read this also. The oxidized hydrocarbons and ozone in presence of humidity causes photochemical smog. Humidity. Hydrocarbons combined with oxygen, nitrogen dioxide, nitrous oxide, ozone, O3 peroxides, formaldehyde, peroxyacetyl nitrate are formed. So it is oxidizing in nature, of course. Why so? Because when NO2 is combining with hydrocarbons. We are getting peroxides, formaldehyde. So it is oxidized everywhere. So of course it is oxidizing in nature and it causes irritation to eyes, lungs, nose. Asthmatic attack also comes and damage plants. So option number D is completely wrong, and they were asking us the same thing. Which of the following is not correct? So option number D is not correct. Cool. Question number 7. The greenhouse effect is because of presence of gases which in general are strong infrared absorbers in the atmosphere, presence of CO2 only in the atmosphere, presence of ozone and some CH4 in the atmosphere, and 2 and chlorofluorohydrocarbons in the atmosphere. So greenhouse effect is basically heating of atmosphere, heating of atmosphere due to absorption of radiation by greenhouse gases. Okay. So basically, they are asking me about greenhouse gases, that which of the following is a greenhouse gas. So of course, let's read out the statement. Greenhouse gases such as CO2, ozone, methane, chlorofluorocarbons, and water vapor form a thick cover around the Earth, which prevents the infrared radiation emitted by the Earth to escape. Why it prevents? Because it absorbs IR rays. It gradually leads to increase in temperature of atmosphere, as I told you. So water vapor is the largest contributor to the Earth's greenhouse effect. However, water vapor does not control the Earth's temperature. So option number is saying same thing, presence of gases, which in general are strong infrared absorbers in the atmosphere. And why infrared absorbers? Because wavelength of infrared rays is comparable with the size of these gases, or you can even say particulate matter. Okay, so that's why infrared absorbers are those where wavelength of, so basically they absorb infrared rays because of this thing only, that the size of these is comparable with the wavelength, so they absorb infrared gases. That's why I can say that greenhouse gases because of the presence of gases which in general absorb infrared rays and keep our atmosphere heated by absorbing these rays. So again, this was an easy one. Question number 7. Okay, so let's continue with question number 8. So in question number 8, it's saying which of the following is hazardous pollutants in the automobile exhaust gases. So N2, CO, CH4, oxides of nitrogen. So basically, it is asking me that the exhaust gases which is released from automobiles. Automobile basically means the vehicles which we drive, be it two-wheeler or four-wheeler. So which are the pollutants which are produced in these automobiles? So it can be nitrogen, CO, CH4, oxides of nitrogen. So as we just saw, it is oxides of nitrogen for, of course. So option number 4 will always be there. So let us see the options, because N2 plus O2 combine to give you NO plus NO2. Okay, but we have to check that answer which is the most correct one, because in these type of questions many times it happens that many options can be correct. So in that scenario we need to check that answer which is the most correct one. Okay, So option number C, CO and oxides of nitrogen are poisonous gases present in automobile exhaust gases. Because I told you that option number 4 will always be there because it is released to automobiles only. Okay. So C, second and 4 is the right option. CO and oxides of nitrogen. Okay. So option number C is the right option to this question. So moving ahead, question number 9. The liquefied gas that is used in dry cleaning along with suitable detergent. So why liquefied gas? Because we use it in cleaning, and in cleaning we can't use a gas that is volatile, because volatile gas basically moves away. So we need to use a suitable gas which can be used in cleaning. Dry cleaning basically means that cleaning only which we give, like when we give our clothes for dry cleaning. So what gas is used there? They are asking this thing. So it would be carbon dioxide with a suitable detergent is used in dry cleaning. Why? Because carbon dioxide is, first thing, liquefied. It can be liquefied easily. That's why we also call it as dry gas. Okay, so it is used in suitable detergent, and of course we must have heard about two compounds. One is washing soda, which is sodium bicarbonate. So in this type of compounds, basically CO2 is only used for dry cleaning. So option number A is the right option. CO2, basically used in form of bicarbonate. Okay, so option number A is the right option to this question. Okay, so let's move ahead. Question number 10. Roasting of sulfides gives the gas X as byproduct. So roasting of sulfides basically means, roasting means in presence of oxygen. This is a colorless gas with choking smell of burnt sulfur and cause great damage to respiratory organs as a result of acid rain. So since they are talking about acid rain, it might be H2SO4. Basically, that sulfide of oxygen will combine with oxygen to form that sulfur compound will combine with oxygen to form H2SO4. Its aqueous solution is acidic, which means H2SO4 acts as a reducing agent, H2SO4 again, and its acid has been isolated. Again, it means sulfuric acid only. So we need to find that gas which on reaction with H2O and O2 gives me H2SO4. And that gas is formed by roasting of sulfides with oxygen, because roasting happens in presence of oxygen only. So again, SO2 is the right option. Here SO3, SO2 and SO3 are the only two gases which react with H2O to form H2SO4. Okay, so these are the only two gases which react with H2O to form H2SO4. Okay, and these two are given here, but you need to take that gas which is, first thing, colorless, and SO3 is not colorless. SO2 is the only colorless gas, and SO2 gives you choking smell of burnt sulfur, which is not there with case of SO3. So SO2 is the right option here. SO2 is the right option here. Okay. So among these four, please remember, first thing, if you want H2SO4, you need these two, and among these two, SO2 is colorless, and it also gives me choking smell of burnt sulfur. Choking smell means, how do I explain choking smell? It's basically a kind of smell which you get when we burn something like, so choking smell. Okay. So please remember these properties of SO2 because they might be asked again in JEE Mains. Cool. So let's move ahead with question number 11. Which of the following is a sink for CO? Sink means which can dissolve any amount of compound. Okay. So which of the following is a sink for CO? Microorganisms present in the soil, oceans, plants, or hemoglobin. Of course, hemoglobin is not correct. Hemoglobin basically combines with CO to form carboxyhemoglobin. This reduces its capacity to carry oxygen. It means blood's capacity. So doctor also advises that we should not sleep in a room which is completely closed and by burning fossil fuels in front of us for warmness. Why so? Because if the room is completely closed, then the carbon monoxide which is released will combine with our hemoglobin to form carboxyhemoglobin, which is a very hazardous compound because it reduces the capacity of our blood to carry oxygen and we can even die. So it is not advised to sleep in a closed room by burning fossil fuels for warmness. So option number D is of course not correct. We need to find that thing for CO, which is safe actually. So option number A is the safest option. Microorganisms present in the soil is a sink for CO. They convert CO to CO2, thus it's sink. Basically, CO combines with oxygen in microorganisms to form CO2, and CO2 is not hazardous. Well, it is hazardous, but not that much as compared to CO. So microorganisms basically convert CO to CO2 by oxygen. So this is the right option for this question, microorganisms. Okay. So option number A is the right option, which is microorganisms present in the soil. Okay. So moving on to question number 12. Which one of the following statements is not true? Dissolved oxygen in cold water can reach a concentration up to 10 ppm. Okay. Clean water would have a BOD value of 5 ppm. Fluoride deficiency in drinking water is harmful. Soluble fluoride is often used to bring its concentration up to 1 ppm. So when the pH of rainwater is higher than 6.5, this is called acid rain. First thing, it should be above 7, not 6.5, but 6.5 can also work. So acid in the rainwater containing sulfuric acid and nitric acid, which are formed when the oxides of sulfur and nitrogen present in the air as pollutant. So rainwater has a pH below 5.6. So first thing, not 5, sorry, below 7, 7 is neutral. Below 7, we have acids. Above 7, we have bases or alkalis. Okay. Since we are talking about acid rain, first thing we have to talk below 7. Now, for rainwater, we know that when rainwater comes down the earth, it combines with compounds which are present in the atmosphere like SO2, NO2, and combining H2O with these things will give you H2SO4, HNO3. So these acids get mixed in the rainwater, so it gives me acid rain. Okay, so this acid rain basically lowers the pH of rainwater even below 7. So the rainwater has a pH of 5.6 on the neutral level, but it even goes down. So that's why we call it acid rain. So it is not 6.5. The criteria is 5.6, which we can say as threshold one. Threshold criteria. Okay, so this is there in the acid rain. So 7 is neutral, below 7 is acids, and above 7 is bases or alkalis. So acid rain combines with this as a rainwater combines with SO2 and NO2 to form H2SO4 and HNO3. These acids mix with rainwater to give you acid rain. So it has a pH below 5.6 and it is saying 6.5. It has basically inverted it. It should be 5.6. So as I told you, option number D is the wrong option. Which of the following statement is not true? So D is the right option because they are saying which is not true. So D is not true, so D is the right option. Rest all three are true. And these values you can not theoretically derive. You should able to remember these things because from a chapter like environmental chemistry, only these things are asked. So you should remember these concepts. Okay. So this was about the questions which we can which we have got in previous year questions. So this is about that, but we can even move ahead and talk more on that. So let me take a blackboard and here I will explain. So first thing, environmental chemistry. First thing, it is a theoretical topic, so you need to learn the concepts, and only after that you can answer the questions which are being there in JEE Mains or even NEET. So let's firstly talk about the four layers. So basically, there are four layers in atmosphere: troposphere, stratosphere, ionosphere, and at last we have exosphere. So in stratosphere only we have ozone layer. This ozone layer protects us from UV radiation. Okay. So whatever pollution which is done by humans, it comes into troposphere, be it due to SO2, H2O, be it due to CFCs. All of the pollution comes in stratosphere layer. So this is about the basic combination of atmosphere. So moving ahead, pollutants. Okay. So basically CO, CFC, and oxides of N2 and sulfur. These are the three main pollutants out there in our atmosphere. Okay. So CO is responsible for, as I told you, carboxyhemoglobin. Okay, it combines with oxygen to form CO2, and increasing level of CO2 increases increases greenhouse effect, which is causing increase in average temperature of Earth. Okay, so this is about CO. Now CFCs are released by refrigerators. Basically, CFC means chlorofluorocarbons. Okay, and CFC's main thing is they are depleting our ozone layer. they are depleting ozone layer. So government has also issued some rules against the use of CFCs in refrigerators, and we are using other gases to cool. Okay, so coming on to oxides of nitrogen and sulfur. So basically, oxides of nitrogen and sulfur are involved in acid rain. They cause irritation, and they even hinder photosynthesis in plants. Okay. Now, next type of pollutants which we have are particulate pollutants. Okay. So in particulate pollutants, basically it means smoke, which means smoke plus fog. We have mist, we have dust, we have fumes, and all these kind of compounds are known as particulate pollutants. Okay. So we know that smoke is released by cigarettes. Okay. Dust can be coming from sandblasting. Fumes are due to sublimation or condensation of water vapor. So these particulate pollutants are very harmful because they are dangerous to human health, because especially those which are greater than 5 microns. Lodge, sorry, lodge our nasal passage, which will cause us difficulty in breathing. So these particulate pollutants are very harmful for human health, and above 10 microns can even harm our lungs. So particulate pollutants are of course very harmful for a human being, like leaded petrol. Leaded petrol was a primary source of airborne pollution, and that petrol was causing harm to human pollution. That's why nowadays we are using lead-free petrol. Then coming on to smog, we have photochemical smog, which we have already discussed. So next we have how CFCs are formed. So basically, when CFCs are released by refrigerators, they move to stratospheric layer, where these reactions take place. CFC is CF2Cl2. Due to UV radiation, it breaks down to free radical Cl, of course gas, plus CF2Cl is left alone, again in a form of free radical. Okay. Then this Cl free radical combines with oxygen, not oxygen, ozone, sorry, to form ClO free radical plus oxygen, again in a gaseous form. Okay. So this ClO free radical combines with oxygen to form Cl free radical plus oxygen. So in this way, ozone layer is completely depleted. Ozone layer is completely depleted. Okay, so this is the only reason for ozone hole. Ozone hole basically means depletion of ozone layer only, which is giving us direct infrared radiations, which can cause many problems like skin cancer and all those kind of stuff. Okay, so this is important that we should stop the use of CFCs, and government is trying to do that only. Now moving ahead, moving on to BOD and DO, which we talked. So BOD is biologically, not biologically, biochemical, biochemical oxygen demand. DO is dissolved oxygen. So these two are basically important for underwater animals like fishes, because for them to for them to do respiration, they need dissolved oxygen. So basically, clean water should have a BOD value of less than 5 ppm, and highly polluted water have a BOD value of 17 ppm or more. So these BOD values you should remember, because these are asked directly in JEE Mains. Now there is a process which is called as eutrophication. Eutrophication. So in this eutrophication, animals which are present in water bodies, that is, animal life in water bodies like fishes, is deprived of oxygen. So if there is a there is a lack of oxygen, they will not be able to respire, and if they will not be able to respire, then they will die. So this phenomena is known as eutrophication. Again, an important formula which can be asked. And other than that, there are many other pollutants, like as I told you, lead, sulfate, nitrate, and other metals. So there is a table which is given in NCRT from where you can check. So there they have given you the values of different pollutants which should be present in a certain amount in atmosphere. If they cross that value, then that would become harmful for us. So they have been given in the NCRT, but let me write it down here. Iron, iron should be zero point 0.2 ppm, not more than that. Manganese should be 0.05 ppm. This is in drinking water. If the values exceeds, then the water would be poisonous. So iron should be zero point 0.2 ppm, manganese should be 0.05 ppm, aluminium should be zero point 0.2 ppm, and these values you should remember because these are asked many a times in JEE Mains. Copper should be at most 3 ppm, zinc should be 5 ppm, and cadmium, which is very harmful, it should not exceed 0.005 ppm in dissolved water, in drinking water, because otherwise the water would be harmful for us. These values for these pollutants you should remember because these are quite important. Okay, so this was about the pollutants. Green chemistry, I already told you. Green chemistry means the stoppage of use of harmful chemicals to stop pollution and to improve the health of workers which are involved in these industries. Okay, so This is about green chemistry, where we use, like we talked about dry cleaning of clothes, where we use carbon dioxide for dry cleaning. Then we use it in bleaching of paper, synthesis of chemicals. So this is all about environmental chemistry. Again, it is a theoretical topic for JEE Mains. If you learn the things, it is better from this chapter, because JEE Mains ask these type of questions to test your knowledge. So if you are, basically what I will advise you, if you have read this chapter from NCRT, then you are good to go for JEE Mains. So please try to memorize these chapters, which are like environmental chemistry, like the chapters which are given in the end of organic chemistry. These chapters gives you direct questions. Even sometimes 3 4 questions are being asked, and these are direct questions. If you know, you have to mark it, otherwise you have to leave it. So please try to read these chapters from NCRT. NCRT book is more than enough for means and need. So yes, you should learn these things. Otherwise, you will waste your time on these. And basically, these questions only tell you that you just mark us and move on to next questions, maybe to the math section or to the physics section, which will consume more time. Okay, so this was about environmental chemistry. Rest we can see. We can even check more questions which were there in the past year from NEET and JEE to practice. And rest is all good, as I told you. So this was about the chapter. Rest we can meet in our next session. Till then, okay, bye bye.